Actually works. Okay. Yeah, just what a treat to be back at Computel and see so many familiar faces and some new ones. Really excited to be giving this talk about something that we had a lot of fun doing. Um, let's see here. Yeah, so our talk is called Zero-Shot Query Generation for Approximate Search Algorithm Evaluation. Hopefully that'll make sense at the end of the talk. My name's Aidan Pine. We're kind of cross-organization group of people that worked on this. So myself and my colleague Pat work at the National Research Council in Canada in the Indigenous Languages Technology Project. We were also joined by David Huggins-Daines, who I think is online, and Carmen Leeming, both independent researchers. Heather Suter, hi, in the back of the room there from University of Winnipeg. Timothy Montler, who's professor emeritus at the University of North Texas, and Mark Turin at UBC and currently University of Tokyo. So what was the motivation for this project originally? So as we've heard in presentations today, and as I think most of us know, online dictionaries are extremely common and valuable tools for language learners in Indigenous language revitalization contexts in Canada, but also abroad. Almost a decade ago now, we developed a system called Mother Tongues Dictionaries, which is kind of like a self-hosted platform for visualizing pretty simple lexicographic data, visualizing your dictionary. And it was intended to kind of reduce the hurdles that people had in publishing their dictionary data and making it accessible to the communities that they wanted to. It's been in use for almost a decade now, and we actually published a kind of version of the predecessor in 2017 at Computel, so there's some continuity there. Some kind of key features of it are that it supports web, iOS, Android development, and importantly for this talk, allows for customizable approximate search. So as we wrote about in that paper and also in 2017, people have been writing about this. I think Michael Maxwell and Bill Poser wrote about this in 2004 too. Approximate search is not just a kind of nice to have thing in a language learning context. It's actually a real requirement. And that's because of this kind of dictionary paradox. So, if we're using an English dictionary as a monolingual English speaker, you just look up a word and you know how to spell it because you're an English speaker and you're literate. But if you're learning a language, maybe you don't know exactly how to spell that word. And maybe you're wanting to use the dictionary because you're wanting to learn. If you don't know how to spell the word and you're trying to look it up, there's this frustrating experience of knowing that it should be in there, but not being able to find it. And so approximate search is really important to kind of help us find the words that we want to. And Mother Tongues Dictionaries has multiple possible approximate search configurations. And this has left us with the question over a long period of time of like, okay, well, which one do we choose? How do we choose which approximate search algorithm configuration to use here for given language? That leads us to another question, which is how do people misspell words and why? And as you can imagine, there are a lot of answers to this. There's so many different ways to misspell words. There's probably an equal number of ways to misspell words as there are people in this room, more so, right? And there's a variety of reasons why. So people might not have the right keyboard, so they know exactly how to spell it, but they just can't actually type the characters on the device that they're using. They might be using a legitimate different variation of that word, like there might be alternate orthographies that they're using, or they might have misheard a particular sound or confused it for something else. So you could imagine that one way we could go about this would be to actually try and record the misspellings that people have in a dictionary. So maybe have a like, did you find the word you meant to, look for? And then people could click a button and select something like that. When we started looking at this, it was actually kind of complicated to do with our privacy policy where we didn't want to capture open input. So people type all types of things into search boxes, and we didn't really want to be recording that and changing our privacy policy across, dozens of languages. Mother Tongues Dictionaries is in use in over 3 dozen languages. We didn't want to go down that route. And also, all these dictionaries are available, if not primarily, then optionally offline as well. So instead, the focus of this paper is to present methods for generating plausible user misspellings in the absence of real data for many of the languages that we're working with. So we did this for two different dictionaries as part of this paper and this project. So the first project that we worked with, that does not look very high resolution on this big screen, but apologies for that. The first dictionary we did is for Sinchothan, and that's our co-author Tim Montler in the back there with Cecilia, Belinda Claxton, and Lou Claxton holding this giant dictionary. I almost brought it for reference, but it's 8 pounds. I weighed it and could not fit in my luggage. It was published in 2018. It is also available digitally, but it's just a wonderful resource. And this is what the orthography looks like in part. It was developed by the late Dave Elliott. As you can see, this is just an excerpt from our paper. There's a lot of symbols that are kind of confusable. So if you're learning this language, you need to know what the difference between a K with an underline, with an acute accent, with a just a plain K, et cetera, is. And there's a lot of kind of similar sounds to English ears. The second dictionary that we worked with was the Michif dictionary, which Heather has had a big part in, as well as David Daines on the call, and Carmen, I should say. Southern Michif is one of 3 languages spoken by the Métis. It's a contact language that combines elements from Algonquian languages as well as Métis French. And this is a picture of Heather in case you have a hard time identifying her here. So our experimental kind of setup for this paper was that we, for both of these dictionaries, we sampled 50 random words from the dictionaries. And then we had a lot of fun developing 8 different ways to generate misspellings for those 50 words, which I'll get into. And then we searched using those generated misspellings and saw in what place the actual word we were looking up ranked in the search results. So for example, just to make that clear, we took this word for number 1, for example, from Sinchothan. We applied a misspelling generation technique, which I'll get to in a second, and it produced that. We would search for that word in the dictionary and see where this word ranked in the results, if anywhere. So we started using, to kind of guide our query generation methods, we started with user personas that we actually wrote about in that 2017 Computel paper. And the first one was for users who can distinguish phonemes, but don't always know the orthographic conventions that they're wanting to use. And so for this, we did a kind of human transcription. So myself and my colleague David listened to the audio for these 50 words, and then just tried to hand transcribe what we heard. So I'll play the audio and you can have a guess at what you think you would do as well.
Pushkuk.
That's the first word.
Nahushpastanak.
That's the second word. And here are the results. So this is the original word along with the IPA. This in the second row here is what we transcribed. And at the very bottom is the character error rate on average for our transcription. So you can see this was a lot harder for Sinchothan. A higher character error rate means it's further away from the original word, and a lower one means it's closer. This was very challenging for Sinchothan, David has told me. The second user persona was for users who know the orthography but can't reliably discern certain phonemes. And we treated this as a data corruption task. So we targeted specific classes of graphemes and phonemes that we expected to be challenging and corrupted up to 3 of them in any of the given words. And so here you can see, for example, that K with the underline at the bottom there, we, for example, corrupted that into another valid K that might have been a confusable for that. The third was imagining users who don't have access to a keyboard or input system for their language. And so this, we just simply got rid of all diacritics or special kind of non-ASCII characters and treated that as the misspelled word. You can see here that there's a lot more special characters in the Sanchothan orthography than there are in Michif. And lastly, users who know an alternate orthography. So we were lucky that there is a kind of alternate format for all the words that we had coming from the Turtle Mountain Dictionary. We didn't do this for Sanchothan because there wasn't really, we didn't want to just invent an alternate orthography, and there wasn't really one to show there. But we got a little carried away, so we came up with 4 more methods that we didn't quite have user personas for, but hopefully you think that they're reasonable. The first one of these extra 4 was to go through IPA. So we started, for example, with this word in Sanchothan, the orthographic representation of the word. We did grapheme to phoneme, so we converted it to IPA. We had a tool that lets us do that. And then we mapped everything to the closest English equivalent in IPA as well. So some of you might remember our G2P library from Computel in 2022 that allows, among other things, to do cross-lingual G2P. And so this is just to kind of have a little code snippet here. This is, you can, from within G2P, you can do these kind of cross-lingual mappings that automate those kind of 2 steps for you. And then the kind of fun part is at the very end, we trained a kind of G2P in reverse system. So we did a phoneme to grapheme system for English, where we just reversed the columns essentially of a pronunciation dictionary and trained a sequence-to-sequence model using deep phonemizer. And this lets us go from the English IPA representation of a Sanchothan word to English. And that's what we got there. We've released this model, so you can go get it on Hugging Face. We also trained one for French. So if you wanted to replicate this for a language that you're working on, you would need to be able to map from your language into IPA, but then you could deterministically figure out how to map to the closest English or French IPA equivalents and use one of these 2 models to get a kind of English or French approximation of the word. It's 2025, so we also use an LLM despite my reluctance. But for this, we kind of tried to leverage some of the model's internal understanding of IPA, provided it with IPA of the words here, and then asked it to produce English or French orthography. We also used ASR, so similar to some of the other talks here, we used a speech foundation model. We used Wave2Vec2 with a greedy decoder, so not combined with any sort of language model for these languages. And we didn't fine tune it on any language that we have. I'll play the audio again so you can kind of compare what the ASR system's decoding was with what you hear.
Pushkuk.
Nahuspastanac.
And then lastly, and probably most importantly, we also got teacher-curated misspellings. So we asked people who are also co-authors on our paper, who are experienced and experts in teaching these languages and working with these dictionaries, what the most common misspellings were for the words that we had, and we wrote down those as well. So now we had those 8 methods times the 50 different words that we got. We have 400 different misspellings for each of the languages that we're working with. And we wanted to evaluate the results with our different search algorithms. So Mother Tongues Dictionaries allows for both weighted and unweighted edit distance. So unweighted edit distance is just the number of single character additions, deletions, or substitutions required to transform the query into candidate search terms. So you have a word like cat, for example, here. If you had cat in the dictionary, that would get an edit distance of 0. There's no changes needed. Hat would have an edit distance of 1 because you changed the C to an H. And dog would be an edit distance of 3. But we can also weight those changes. So, for example, we could say that C to K substitutions or vice versa only cost 0.5. And so maybe if we search for KAT, we could get cat being an edit distance of 0.5 and hat being an edit distance of 1. In addition, the more recent version of Mother Tongues dictionaries also uses BM25 as a secondary score. I'm seeing the time, and I also don't have too much time to get into an in-depth discussion of what BM25 is, but it's related to term frequency, inverse document frequency, if folks are familiar with that. It prioritizes frequency of the query term in the dictionary overall, and also length of the search item that you're looking at. So to summarize, we tested 4 different search strategies, the weighted and unweighted, and we already had weights, by the way, I should say, because these were in-use dictionaries. We had weights for these, but we compared the unweighted and weighted edit distance with and without BM25. And we evaluated it using mean reciprocal rank, which is this equation here, where Q is the 50 words that we were looking at for each system, for each type of query generation that we used. So as an example, just to break this down, imagine we took the original word like peshkok, and using one of our query generation methods, we got peshkop, which is what I transcribed it as. We would then search for peshkop, report the reciprocal rank, so 1 over where it appeared in the dictionary. So if it appeared in the second spot, it would be 1 over 2 or 0.5. We did that for all 50 words, and we reported the mean, the average there. So this is just an excerpt from the results from our paper. And just to recap, a perfect reciprocal rank then would be 1.0. So these are all values between 0 and 1. Perfect rank would be 1.0. 0 would mean that it wasn't found in the search results at all. If it was 0.5, it was found in the second spot, 0.33 in the third, et cetera, et cetera. So this is a huge table, so I'm going to kind of break down some of the insights. The first insight is that, so I've arranged this so that for Sanchothan anyways, it goes in order of character error rate. So as character error rate for the query generation techniques that we developed increases, we see the mean reciprocal rank decrease. And this makes sense because as the query generations produce more and more misspelled words, like words that are misspelled worse than others, it's going to be harder for any of our search algorithms to be able to return the correct word. The second observation here is that the addition of BM25 actually shows improvements for all of the query generation techniques across both weighted and unweighted edit distance. So if you compare in this first column, we have the unweighted edit distance, and in the last column, we have the unweighted edit distance plus BM25. And then similarly, in the middle, we have the weighted edit distance and the weighted plus BM25. Across all of the query generation techniques, there's improvements when we add BM25. And kind of surprisingly, we don't see much of a conclusive difference between the weighted and unweighted edit distances here. So this is a little counter to what we thought going into it, because, well, maybe partially informed by just like the intuitive explanation that I had earlier about weighting. It kind of makes it seem like that should represent something we know about the language and misspellings. And it also takes a lot of time to write the weights. So we kind of like, you hope that it's doing something good, right? But we don't really see anything conclusive here about that. And so I think that could be one of a couple things. One, it could be that actually our misspelling generation techniques here don't represent, they're missing something. They don't represent the actual misspellings that the people who are writing these weights assumed. Although we don't see the difference in the teacher-informed misspellings. It could also just be that writing these weights is actually a very, very hard thing to do beyond that extremely trivial example that I showed. So it kind of makes sense when I do the cat in the hat kind of explanation. But if you're actually doing this for many different kind of use cases in a language, and you're actually trying, and they might interact with each other, these different substitution weights or addition weights and things like that, that might be causing a problem here. So future work, we want to see how well these query generation techniques match actual user queries. That would be great. We looked at a couple data sets, but couldn't really find anything that exactly match what we want to do here. We also were interested in how these query generation techniques varied across different languages and dictionaries. So are they more useful or helpful for some dictionaries or for others? We then wanted to look into whether these methods could be used to improve the weighted edit. Yeah, sorry. Improve the weights for the weighted edit distance. Maybe we could have a model learn from this data, whether it's the real data or the synthetic data or both. And we also want to investigate this with some more kind of morphologically aware query generation methods and particular focus on highly polysynthetic languages. So mahalo, thank you. I did it in 22 minutes in my hotel room and shaved 10 seconds.